Alright, so today we're going to be learning about velocity, displacement, and vectors. What I'm going to do to start off is I'm actually going to give you a little bit of demo. So I've got my bike here, and I'm going to ride just about 100 meters down the block and then come back. Alright, so I sped that video up for you guys a little bit just so you didn't get bored, but basically, so I rode my bike down there and I came back. So I'm going to ask what was the average velocity of that trip? And you guys are probably thinking, I don't know, 15k an hour, 20k an hour. The answer is 0. My average velocity was 0. Surprising, right? So now we're going to do a little bit of a lesson. We're going to figure out why was my velocity 0 for a trip up and down the block. That just doesn't make sense.
Alright, so let's take a look at this KWL chart and we'll fill it out for what we know and what we'd like to learn. So what we know right now is that speed is distance traveled per unit time of an object. Speed is represented by a lowercase v, and we also know that the formula for speed is equal to distance over change in time. What we would like to learn from this lesson is what is velocity. We also want to know how we find velocity, and we're going to want to know what a vector quantity is. Finally, we're going to define the difference between speed and velocity. Before we get into velocity, however, I'm going to take a quick moment and talk about displacement. So displacement is the distance that an object has traveled relative to its starting position. So what does that mean? Well, it's the shortest path from where an object started to where it is now. It has nothing to do with the total distance traveled, it just deals with where the object started and where it is now. So the direction of displacement is also important. This is what's known as a vector quantity, which we're going to talk about in a little bit. Displacement can also be positive or negative, depending on which direction it is. Conventionally, displacement to the right would be positive and to the left would be negative, but it can also go in multiple dimensions, so north, south, east, west. And again, we'll talk about that in future lessons. Displacement is represented by the symbol, it's a lowercase d with a little arrow accent over the top. So now we're going to move on to velocity. What is velocity? Well, velocity is a measure of an object's total displacement per unit time. Again, direction of velocity is important. And it can be either positive or negative, depending on which direction it's going. And when you add them together, it's important to keep track of the positives and the negatives. Again, it's a vector quantity like displacement, which I'm going to talk about right after this. And it is represented by a lowercase v with that same little arrow accent over the top. The formula for velocity is equal to displacement over time. So vectors and scalars. I've mentioned vectors a couple times already, so now I'm going to talk about what they are. But first, I'm going to talk about scalars. So scalars are what we're used to. It's what we've been using so far. They're measurements that are only in magnitude. So speed, distance, time. We're only worried about how much. We're not worried about direction or anything else. Vector quantities, now we're worried about magnitude and direction. So this is velocity and displacement, and there's more we'll learn about in the future, such as force. Vectors can all be positive or negative, and vectors can be added in multiple dimensions. So in this course, we'll only go as far as 2 dimensions, but in future, you can go even into 3 dimensions and add vectors together. All vectors are represented by that little arrow accent above the symbol. So now let's go back to the bicycle example, and we'll figure out why the velocity for the total trip was 0. So let's start out with just the trip out. So I went about 100 meters out, and it took me about 20 seconds. So to find the velocity for that, we'll use our velocity formula, displacement over change in time. So that's just 100 meters over 20 seconds. The final velocity for that is 5 meters per second. Now if we did the speed for the same trip, you'd find that the speed is also 5 meters per second. Where velocity differs from speed, however, is on the trip back, and that's where we start to deal with displacement. The bike starts and ends in the same position. Therefore, our total displacement is actually 0. To show this mathematically, we can add the displacement of the trip out and the trip back. So the trip out was 100 meters, and the trip back was 100 meters as well. But the trip back was in the opposite direction, so it's actually negative 100 meters. So when we add those together, it's just 100 minus 100, which is 0. So that's where we get the total displacement being 0 from. So if we use that to find the velocity, we'll find that the velocity is also 0. So when we plug those numbers into the formula, we get 0 divided by 40 seconds, which is equal to 0. So now I'm going to use this comparison chart to compare speed and velocity, just to get a sense of how they differ from each other. So speed is distance per unit time, whereas velocity is displacement per unit time. Secondly, speed is a scalar quantity, whereas velocity is a vector quantity. What that means is speed, only magnitude is important. And with velocity, we're worried about both magnitude and direction. For speed, the symbol is a lowercase v, and for velocity, it's lowercase v, but with a little arrow accent above it. The formulas are similar as well. Speed is distance over time, and velocity is displacement over time. So finally, let's just come back to our KWL chart, wrap it up, and let's show what we've learned so far. So we've learned that velocity is an object's displacement per unit time, and that it's a vector quantity. It's represented by the lowercase v with the accent above the top. We've also learned what vectors are. Vectors are a quantity with a magnitude and a direction. And we have also learned the formula for velocity, which is velocity is equal to displacement over time. I hope this introduces you to the concept of velocity, kind of gives you a little bit of an idea what we're going to be working about in the future. Thanks a bunch for watching and learning with me today.